Alright, we're going to look at the outer planets, starting with Jupiter. Jupiter is going to be the first of the outer planets as we move away from the inner planets with Mercury, Venus, Earth, Mars. We have the asteroid belt, which contains some dwarf planets or Plutoids. And then we get to Jupiter, which is the first of the outer planets, and it's a gas giant, fifth planet from the Sun, and the largest planet in our solar system. It has more than twice the mass of all of the other planets combined. Jupiter is very, very large in terms of a planet. When we look at all of the mass in the solar system, the Sun takes up about 99% of all of that mass, and the remaining mass for all of the planets, moons, satellites, asteroids, comets, and other objects in our solar system, that's 1%. Jupiter is twice as big, essentially, as all of the other planets. So Jupiter makes up a good part of that 1% that's remaining or left over outside of the Sun. Jupiter rotates faster than any other planet, and the way they calculate that is they look at the clouds in the upper atmosphere, and they kind of calculate how long it takes those clouds to come back around and make one full rotation. Jupiter really doesn't have a solid surface, so it's tough to exactly calculate how long a day on Jupiter is, but its upper level clouds do spin very, very fast as the planet rotates. It has the strongest magnetic field of all the planets in the solar system because of its size. It's going to extend larger than any other planet. Continuing on with Jupiter, it has what we call a giant storm, the Great Red Spot. It's 3 times the size of the Earth, essentially a hurricane that's been whirling around the planet for as long as we've been able to see that, since Galileo got his first telescope and pointed it towards the planet in the 1600s, around 1610. It's been there, and it doesn't appear like it is going anywhere. We see other smaller storms that do pop up and leave, but that big red storm really has been pretty constant. It does turn and swirl, so it is active and moving, but it doesn't seem to be dissipating or weakening in any way. Jupiter does have rings. They are very, very small and not easily visible, not nearly as numerous as Saturn, but the rings do exist. Jupiter does resemble a star in its growth and composition, but it didn't grow large enough to ignite. Jupiter does actually re-radiate more energy than it receives from the Sun. So as gases, as they're getting compressed, and we talked about that earlier in the year when we were talking about weather and water, as gases are going to get compressed, they are going to start to heat up and warm up. So Jupiter does actually give off some of its own heat to the surrounding area or close to it. So it's going to actually, very importantly, re-emit more heat than it receives.
One announcement: if seniors pass their capping on money, you can see Mr. O'Malley after the time.
Here is a picture of Jupiter. With these pictures of Jupiter, you could see how it is a swirling ball of gas, and it has a great red spot here. This is the spot that is 3 times the size of the Earth. When we look at some of these other circular storms that pop up on Jupiter, they don't seem to last quite as long, but this is the big one here, the Great Red Spot, and again can fit 3 Earths inside of that. Jupiter does have a lot of satellites or moons. With those satellites and moons of Jupiter, some of the things that we're going to point out there, the satellites, one, are just the natural satellites, and we refer to them as moons. But we're going to look at the 4 largest. So one of the large ones is Io. It's the most volcanically active body in the solar system. You can see some similar qualities to that of Venus. This is more volcanically active than the planet Venus. Next we have Europa. Europa's surface is mostly ice, and there is evidence that it may be covering an ocean of water or slushy ice beneath it. And there's some different theories on what makes it liquid and why it might be still liquid underneath. We see jets or geysers occasionally coming up off of the surface with liquid water, or cracks in the ice that could lead to water then filling up and sealing that back off. But it would be pretty interesting to be able to see if there's actual liquid water there. Liquid water is very, very important as we look for potential life other places in our own solar system, and we feel that liquid water is vital for that. Ganymede is the next one. That's the largest moon in the solar system. It's larger than the planet Mercury, and it's the only moon known to have its own internally generated magnetic field. So it's very, very important that this being the largest moon in our solar system. Again, not a planet because it doesn't orbit the sun. So that's one of the main criteria for being a planet. I want to make sure to point that out because that question always does come up. If it's that large, how come it's not a planet? And that's because it orbits Jupiter and not the sun. And last but certainly not least, Callisto, which is a very, very large moon of Jupiter. I believe the second largest moon after Ganymede, and it is extremely heavily cratered, and it kind of gives us a little bit of an ancient view of what the solar system could have been like, with a lot of asteroids and things like that floating around before everything got into the orbits that they're in today, and everything is kind of nice and neatly organized into their orbits that they have now. There would have been a lot of collisions, and we see a lot of craters. We also see that with our own moon and planets like Mercury as well. Moving on to Saturn. With Saturn, again, further away from the Sun than Jupiter, sixth planet. Takes about 30 years for it to orbit the Sun. Another gas giant that's actually going to give off more heat than it receives from the Sun. The big thing with Saturn is its rings. That's what makes Saturn very, very special, often referred to as the jewel of our solar system. Its rings are made up of chunks of ice and rock. They are not solid. They're just kind of a collection of this little dust and ice and rock. And as the light goes through them, that's what gives it that rainbow effect, or rainbow look with its rings. The rings are very, very wide, but they are very, very thin. They're only maybe 20 meters or so thick, but they are almost 300,000 kilometers wide, or extending off of the planet that far. That's almost the distance from the Earth to the Moon. So they do extend very, very far off the surface of Saturn out into space, but are not very, very thick. Like the other gas giants, Saturn is mostly a massive ball of hydrogen and helium, and it's not very, very dense. It would actually float on water. So it's a very, very unique thing with Saturn, that this ball of gas, even though it is very dense and does have, not very dense, it does have strong gravity and holds moons in orbit, but it would actually still float in water with its low density. Has less satellites than Jupiter, but still has more than 50 orbiting it. Titan is the special moon for Jupiter. It's large enough that it affects the orbits of nearby moons, and it has and the important part here, thick nitrogen-rich atmosphere, which is very similar to Earth's atmosphere billions of years ago, before biology took hold on the planet. So that always gives us a little bit of hope that maybe at some point that planet or that moon could be a possible place to travel to, and maybe set up a station or something like that. So that's why Titan is always an interesting moon when we're studying the solar system, because of its atmosphere. Here's our picture of Saturn. We can see the rings here casting a shadow onto the planet, and then the shadow of the planet falling onto the rings on the backside of the planet. The planet itself is kind of colorless. The clouds are kind of dull and blah and very, very monochromatic, but the rings give it a lot of color, and that's what makes Saturn the more interesting planet, and what gives it its unique features are those rings. Moving on from there, we have Uranus, the seventh planet from the Sun. Makes an orbit every 84 years. It's the only gas giant planet whose equator is nearly at a right angle to its orbit. We feel that it might be due to a collision with a planet-like object that would have tipped it on its side, essentially making it spin around like a rotisserie chicken. Instead of rotating right to left, it would rotate up and down. Uranus has more methane, and it's mainly hydrogen and helium, but that's what's going to give it its bluish green tint. It has 27 satellites orbiting it. So those 27 satellites orbiting it, they are going to go around just like the planet rotates up and down. So we get an idea of what the planet looks like here. We can't see its rings, but we can see the bands of clouds moving in an up and down fashion rather than going across like a lot of the other planets did. And here's a little better idea. You can see some of its rings and some of the moons that go around it. Okay, and last but certainly not least of our planets in our solar system is Neptune. It is the 8th planet from the Sun. It is a dark, very cold planet whipped by supersonic winds. It's more than 30 times as far away from the Sun as the Earth, and it would take Neptune about 165 years to make one orbit around the Sun. Very similar to Uranus in terms of its size, shape, and color. Neptune is a very, very interesting planet only because it's one of the first planets, or only planets, that we found through mathematical predictions rather than through regular observations of the sky. Looking at the orbit of Uranus, we found that it doesn't orbit it nearly the way it should, and we couldn't explain the differences in Uranus's orbit, and we found that mathematically there had to be something there pulling on its orbit. So that's when then we were able to point a telescope in the area where there should be something pulling on Uranus, and we found Neptune. So more through mathematical predictions. It has 13 satellites orbiting it. Here's our picture of Neptune. One of the things I want to point out is we should notice as we go through the outer planets, the number of moons really decrease. We see Jupiter with 60 or more, Saturn with more than 50. Then we get to Uranus with 27, and we finally get to Neptune that only has 13. So that's one common theme that we see through this outer planets. We're going to stop there for today, and then we'll do another video or two finishing up some of the other objects in our solar system, and then getting to life and death of stars and galaxies. Actually, looks like I have enough time to finish off the rest of the information for the outer planets in our solar system. So moving on from here, we're going to start talking about what is a planet. So there's 3 criteria to be a planet, and the reason we're looking at this now is as we start to look at Pluto being reclassified and no longer a planet, we're going to look at what the actual criteria is for being a planet. So one of the first things is that it must orbit the Sun. So that's what then rules out a lot of the moons of other planets. 2, it must be big enough for gravity to squash it into a round ball. So up until this point, Pluto actually fits these first 2 categories. The problem was as we started looking with better telescopes and better technology into this outer solar system, or outer part of the solar system, and these Kuiper Belt objects, we found over 40 other objects that fit this criteria as well. So rather than adding 40 new planets to our list of planets that we already have, we decided to actually reclassify some of these. So in 2006, astronomers came together and came up with a 3rd criteria for planets, and this is where then Pluto is going to be then reclassified as a dwarf planet or a Plutoid, because it must have cleared objects out of the way of its orbital neighborhood. So for it to do that, it needs to be large enough to either pull objects into itself or have them orbit around itself, or get them out of its orbital plane and then send them into outer space. So a lot of these Kuiper Belt objects are thought of as objects that might have been closer to the asteroid belt and Jupiter, and even maybe Saturn, and then because of their immense gravities were slung off into this outer part of the solar system. So that's then where it's going to change what the definition of a planet is and reclassify other objects, because Pluto has objects within its orbital plane that it hasn't cleared out of the way, and that's because it's